Hey, what's up guys? Welcome to the fourth and final part of switching to Ubuntu GNOME. In this video I'm going to focus on securing my system, but before I get started I just want to say that these are simply the steps that I would usually take to secure my system. This is by no means a guide that is authoritative or intended to make your system bulletproof, so please do not treat it as such. Another thing I'll say is that my personal take on security is to strike a kind of balance between pragmatism and security. I could be paranoid about security and use all kinds of security software and really limit my system, but I still want to enjoy my system, so I'm not going to take any security measures that I believe will hinder my experience. So whilst I might not be totally secure, I'm still a lot more secure than I will be at the start of this video when I'm finished. The first thing I want to do is set up a virtual private network, or VPN for short. A VPN can offer numerous advantages depending on your circumstances. However, no matter who you are or where you are, using a VPN will offer two distinct advantages in my view. Firstly, improved security, and secondly, improved privacy. Using a VPN, all of your network traffic is going to be encrypted, securing it from prying eyes. Consequently, you're going to have improved privacy because no one can intercept your payloads and view what you're sending to various servers. You can also use an alternative domain name system, keeping your ISP in the dark about how you're using their service. Also, because all traffic is being routed via a VPN server, the server from which you are requesting or supplying a resource will never see your real IP address, giving you that layer of anonymity that some people value. In order to use a VPN with Ubuntu, we must first install what is known as a VPN client. The most popular VPN client is called OpenVPN, so we'll install OpenVPN. We're also going to install a package that will integrate OpenVPN with the GNOME Network Manager, which is essentially what you're looking at here. In fact, we can do this in one fell swoop using the following command. We can say sudo apt-get install, and we'll install a package called Network Manager OpenVPN GNOME. This will install OpenVPN as a transitive dependency if it's not installed already, as well as the program that you need to get that integration with GNOME. I'll enter my password, but as you can see, it's already installed. Now when I go to the Network Manager, I can click on this plus icon to add a new connection. I'll select VPN, and because we installed that package, and only because we installed that package, we have an option to create an OpenVPN network connection. I'm going to give this a name. I'll specify a gateway. Under authentication, I'll change the type to password. Next, I'll enter my username. And now my password. And under certificate, I'm going to explore, go to downloads, and OpenVPN, I'll choose ca.crt. Now, you're obviously not going to have this folder in your downloads folder by default. I downloaded it. And similarly, I've kind of skimmed over what my gateway is and where I'm getting these credentials from. You need to pay a small fee to a particular service in order to gain access to a VPN server. Once you've paid that fee, typically between $3 and $5 a month, they'll give you the gateway, they'll give you the credentials, and they'll give you that CA certificate that you need in order to make your connection work. Finally, under advanced, I'm going to enable LZO data compression. Next, I'll press add, and I'll click on London VPN and enable this toggle. And as you can see in the top right, we are connecting, and now we are connected to the VPN. We can verify this by going to the browser and then going to a website such as ipleak.net. And as you can see, this IP address is not my actual IP address. That might be a little bit difficult for you to appreciate, seeing as how I never did show you my actual IP address. However, it seems to think I'm from London when I am not. I am based in the United Kingdom, but I am not based in the city of London or anywhere near it for that matter. The great thing about this website is that it can also detect WebRTC leaks, which aren't relevant to Ubuntu. They're only relevant to Windows, I believe. I think they might also be relevant to FreeBSD. But if you're seeing your real IP address surface as a WebRTC leak, then you need to Google how to prevent that, typically using some kind of browser extension. And DNS leaks are still relevant to Ubuntu. Basically, every server that you might request a resource from or supply a resource to has an IP address. Servers are just computers plugged into the internet like yours. They just run specialized hardware and software intended to respond to requests very quickly and scale and all that kind of good stuff. And if you want to, for example, go to Google server, you don't type in that server's IP address, you type in google.com. That is a domain. However, somehow you need to find out the IP address, the server's IP address. And the way that you do that typically is via a domain name system. When you go to google.com, your computer makes a request to a domain name system and says, hey, look, I want to know the IP address for google.com. Can you please give it to me? The domain name system says, yeah, I see a website called google.com. Here's its server IP. If it can't find one, you get some kind of error page powered by the domain name system typically. You ever noticed how if you're using a particular ISP, when you go to a page that can't be found, you see the ISP's logo? That is because there are many different domain name systems out there, and by default, you'll probably be using the one maintained by your internet service provider. That's why you see their logo on pages that can't be resolved. The trouble with this is that your ISP have your name, your address, all your personal information and stuff like that, and they can also see which domains you've attempted to resolve. So they'll basically have a list of domains. They'll see that customer 123 with this name, this address, requested the website google.com at this time, and we gave it to them. And they'll see what is equivalent to your browser history. This is a little bit disconcerting in my view in terms of privacy, so it's important to ensure that your IPS cannot see what you're doing by ensuring that you do not have a DNS leak. If you do, you need to set up an alternative domain name system, which is fairly easy on Ubuntu and frankly on Windows too. Right now we are connected to the VPN, and that is great. However, there's a small problem. If I were to log out and then log back in, or restart my computer and log back in, I would not be automatically connected to this VPN. What's more, if the VPN for some reason is disconnected, it's just going to continue using my normal internet connection unencrypted. So if I'm performing some kind of long running task where I may be away from keyboard, it would continue using my normal connection, which I don't want. Ideally, it would try and reconnect if it's disconnected. Unfortunately, there is literally no options inside of the network manager to either automatically connect or reconnect in the case that you're disconnected, and so we have to relinquish this to a script. I looked around the internet a little bit to see what other people were doing, and I came across a solution that works pretty good for me. I found this script right here. The rest of the blog post isn't really relevant to me. Even the method he uses to make the script run on startup doesn't apply here, but the script itself is fine. So I'm going to copy that, and I'm going to go into Sublime Text, which is a code editor, and I'm going to paste this in. I'll edit and describe the script in a second, but for now I'm just going to save it into my home folder, and I'm going to call this connectvpn.sh. So this is a bash script, and the way it works is simple. We start with this while statement that says while true. This condition never changes, it's always true. This makes it an infinite loop, so for however long this application is running, it's going to execute these statements repeatedly. The first thing it does is it queries the status of the VPN connection. The way it knows which connection we're talking about is based on this unique identifier here. His unique identifier that he used in his blog post is different from ours, so in a second we'll replace this unique identifier and this one with ours for our London VPN. If the state is not equal to 5, which I presume means connected, then that means we must be disconnected, and so it's going to try and reconnect the VPN or connect for the first time in the case that we just started our computer, otherwise it'll print already connected, and then finally it waits for 20 seconds before returning to the top of the loop and doing this over and over and over again, because so in a nutshell, every 20 seconds it's going to try and connect if we were disconnected. That's the aspect of the program that ensures that if we are disconnected, we will automatically try and reconnect. So like I say, we have to change this universal unique identifier, and to find out ours, I'm going to open the terminal and I'm going to type in nmcli, which I believe stands for Network Manager Command Line Interface, and we're going to use the C argument, which I believe stands for connections, because we can see now a list of our connections. We see London, which is our VPN name, and in the second column it's unique identifier that we're going to copy. I'm going to select this identifier, press Ctrl D to select the next current, and then Ctrl V to replace them. Ideally, we'd use a variable, but I don't want to stray from the original blog post too much. Great. If I disconnect from the VPN now, and I go to the terminal, what I'm going to do is I'm going to type chmod +x connect VPN. This will make the script executable, so that now we can come here and we can run the script just by referring to it. And as you can see, we're not connected, so it says disconnected, trying to reconnect. You might have seen that in the top right, it was trying to connect, and now we're reconnected. And now in 20 seconds, or probably 15 seconds, it's going to determine if we're still connected. We will be, so it will print something like already connected. If we were to disconnect, it would reconnect. We want this to run in the background, and whilst this script on its own is pretty handy to have running, again, we'd rather have it running as soon as we log in. So let's make it so that this script gets executed when we log into our system. The way to do that in GNOME is by creating a file. We'll use Sublime to do that, and saving it in the I don't really use the graphical user interface to do this typically, so let me do it via the terminal so it's a little bit more comfortable for me. I'm going to say Sublime, we're going to create an entry under config, auto start. I'm going to call this connect vpn.desktop, and we'll save it. And I'm going to copy the entry from my other monitor. Basically, inside of this file, we describe the name of the program that's going to start on startup, and we specify the path to that file, replacing username from a blog post I'm working on. I just use a generic placeholder to my actual username, which is Booker. I tried to use the shorthand to access the home directory, but that really didn't seem to work for some reason, so I like to fully qualify the path. Now, when I log out and log back in, I should be automatically connected to the VPN. We're finished setting up our VPN now, that's all good. Now it's time to install an antivirus. The antivirus I'm going to install is called ClamAV. To install ClamAV, go to the terminal, type in sudo apt-get install ClamAV, and enter your password. Before you can begin to scan directories or files, or your entire system for that matter, you have to update the virus database using the command sudo freshclam. In my case, you're probably going to see that it's already up to date because I installed ClamAV before I started recording and then uninstalled it for the purposes of this video, just because it's been a while between my last video and this one. I needed an antivirus. To understand the purpose of this command, you need to understand a little bit about antiviruses. So antiviruses employ a number of methods to detect malware. One such method, and probably the forefront of any defense, is signature-based detection, which compares the contents of a suspicious file to its database of known malware signatures. What you're downloading when you run freshclam is the database of known malware signatures. If that file contains signatures that have been proven to be malicious, then it's very likely that you have a virus. Signature-based detection can be effective, but it can't defend against malware that has not yet been analyzed by malware researchers or by some kind of dynamic analysis system. You're going to be screwed if you come up against a 0-day or by some new malware or very unpopular malware that's not yet been encountered or analyzed. Anyway, once we've run that, we can run a program called scan. We're going to use the RI flag. R means recursive, which means it's going to look at all of the folders inside of the downloads folder, and then I means only print infected files. This will take a few minutes to run probably. I'm not going to watch it all run, but I'll let it start. Oh, in fact, that ran very quickly, and you can see here that it scanned 2 directories, 31 files, and I have no infected files. You can scan a specific file, or if you look up freshclam on the internet, you'll learn very quickly how to scan your entire system if that's what you want to do. Next, I'm going to install a program called RKHunter, which obviously stands for rootkit hunter. So I'll type sudo apt-get install RKHunter, and it's probably going to ask me at some point for some email options. If you run this, you'll see it ask you for email options. Just don't supply it an email at this time. And then we can scan our computer for rootkits using the command sudo RKHunter. I'm going to use the C argument. And what this is going to do is it's going to firstly check system commands, and then it's going to prompt us if we want to proceed to check the next thing on its list, which will be rootkits, I believe. Press enter to continue, and now it's checking for rootkits, and we can keep doing this. There's a bunch of different steps. There's a flag you can use to automate this. Every now and again you should check for rootkits. You also probably, before running it, want to make sure that you're using the latest version by supplying the update flag. Cool. And there are also other things you want to do with RKHunter. It's a little bit of a complicated program, and I urge you to look at a different tutorial if you're interested in using it. Rootkits are low-level viruses that you want to scan for periodically because they have the potential to be very dangerous at any given time. Next, I'm going to install a couple of other programs just It's not for fun, but just to show you what they are, I'm going to install Bleachbit. Bleachbit is not going to protect you from a virus. However, if you do get infected with some kind of spyware, having run Bleachbit will kind of limit the sensitive data on your computer. It can delete things like your cookies, so your sessions can't be hijacked. It will delete things like your password history from Firefox and Chrome, so password stealers don't work. It will also delete your browser history to improve your privacy. Although in a little bit we'll look at securing the browser and we're going to completely disable the ability to remember passwords because they're very vulnerable. Another thing I recommend you install is a program called Virtualbox. So Virtualbox is not specific to security at all. Virtualbox is a virtual machine. And it's quite a big program. But basically, if you're not familiar with VM or a virtual machine, you can run an operating system inside of an operating system, and you can have that operating system serve as a sandbox, meaning if you have a file that is very suspicious, but you're really eager to run it, you can first run it in a sandbox where the effects are going to be isolated. I don't think it's impossible for a virus to escape the virtual machine. I did read a few months ago probably that is possible, but it's not very likely, frankly. So running things in the sandbox can be a good way to kind of get a feel for what they're doing, what aspects of your system they might potentially change, and if those changes are justified. I'm not going to finish. Oh, as I say that, it's finishing the installation. I'm going to cut the video off here, and then we're going to move on to look at securing Google Chrome, or rather Chromium. I always call it Google Chrome, but it is indeed Chromium. Now I'm going to secure Chromium best I can. If you're looking to use the most secure browser, then use Firefox. Firefox is inherently more secure and better for privacy than Chromium. It's better for privacy because it's not maintained by Google, and secondly, it's better for security because it has a wider range of security extensions available in the Firefox extension library or store, whatever they call it, and also it's far more configurable. You can configure it to be more secure. There are some configurations that we can change for Chromium that will make it more secure, but like I say, the most secure browser I believe is Firefox. However, like I said at the start, I want to strike that balance of pragmatism and paranoia because personally I really value the Chrome developer tools and I just generally enjoy using Chrome, so I don't want to, separate from my favorite browser just for a little bit more security when I can make Chrome pretty secure anyway. So first, let me change some settings in Chrome and then I'll install some extensions to improve security. So I'm going to click on this little burger icon in the top right and I'm going to go to settings. I'm going to search for content. And the first thing I'm going to do is I'm going to enable this tick box that says send a do not track request of your browser traffic. This is going to ask, and that's the operative word, it's going to ask servers not to track who you are and to show targeted adverts. However, they don't have to honor that. Next, I'm going to click on content settings. For cookies, I'm going to do something that maybe you won't like to do. I'm going to say keep local data only until you quit your browser. What this means is that when I log out, when I close my browser, because cookies are kind of the important factor in systems where you log in, right? So when you log in, that state is persisted using a cookie. It means that once you close your browser and all those cookies are gone, there is no longer any state persisted and you're going to be automatically logged out of every website. So if anybody gets to your computer, they can't log into your accounts. I like that. What's more, it means that you can't have viruses running in the background that will steal your cookies and try and hijack your sessions. Next, I'm going to scroll down. I'm going to find location. I'm going to press do not allow any site to track your physical location. I'll press finished. Then I'm going to search for password. And under here, I'm going to uncheck both these checkboxes, or tick boxes. I use them interchangeably. And now I kind of skimmed over the other options. I'm going to talk about this one a little bit because it's kind of interesting. When you tell Chrome to remember a password on your behalf so that it will be automatically filled when you load the login page, you're asking Chrome to store your username and password inside of a database on your local computer. Chrome will encrypt that database. However, if someone manages to get a piece of spyware, such as a password stealer, onto your computer, that password stealer can firstly locate that database. But it's encrypted, right? Well, yeah, it's encrypted, but think about this. If Chrome can encrypt it using a private key, it must also be able to decrypt it using a private key. It has to store that private key somewhere or derive it from some kind of identifier, like a hardware identifier on your system. If Chrome can do it, an attacker can reverse engineer Chrome, find out how they do it, and then do it themselves in their own malware, and essentially find that database file, decrypt it, and then send your usernames and passwords via some kind of network transport to the attacker so that the attacker can then steal your accounts. Password dangers are hugely dangerous because they finish executing so quickly and then they delete themselves. So in a blink of an eye, all your passwords are in someone else's hands. This is contrary to something like a keylogger, whereby the attacker has to wait for you to eventually enter your credentials and hope that you're not using a virtual keyboard or something like that. So the way to prevent this attack is to disallow Chrome from remembering your credentials and to use a plugin like LastPass instead. Now let's talk about extensions while we're on the topic of LastPass. Let me go to the Chrome store. I'm going to search for LastPass, and please don't click off the video yet if you've heard me say LastPass and you're really disgusted. And the reason, for those of you who don't get that, it's Friday today. On Monday, LastPass was actually hacked. LastPass store all of your passwords on their servers. They're strongly encrypted, allegedly, and your password is strongly hashed and all that good stuff. But yes, they were hacked on Monday. I believe a list of usernames, emails, and password hashes were stolen, as well as password hints. However, no databases of passwords were stolen, meaning that your passwords are all secure. So long as you change your password, your account is going to be safe and good. But it is an interesting topic for discussion, whether you should be using something like LastPass to remember your credentials. I like to use it for services that I don't value hugely, or for services I have two-factor authentication enabled for. I do have a very strong LastPass password, so the private key that is derived from that password is also very secure. I'm pretty happy using LastPass, honestly. But for services that I really value, that I know would be dire if they were compromised, I just take it into my own hands and I use a password vault called KeePass. So for things like PayPal and my bank account and even my email address, and for my server passwords and stuff like that, or really database passwords, I don't have passwords for my servers. I use SSH, which, coming to think of it, I should probably have talked about in this video, but I'm not going to. I store all of those in my local LastPass, which means that it's not stored on the server. It doesn't stand to be compromised, and if it is, only I have the password, and I know that to be true because this software is open source, it's audited. I'm really secure in the terms of using KeePass. LastPass, on the other hand, it stores all your data on their servers, which means they stand to be compromised, even though they are encrypted. Very likely that they're encrypted. They claim they're encrypted, they probably are encrypted, but you can't be too sure. Anyway, I'm going to click Add to Chrome. I'm not going to go through the login process simply because I don't want you to reveal the length of my password or anything like that, or for you guys to see a list of my accounts because that's private. But yeah, LastPass is cool. The reason why I implore everybody to use a password vault, be it LastPass or another one, is that a lot of people have a tendency to either choose really weak passwords or to use a decent password but to reuse that password across services. That is hugely dangerous because if you log into a website with the username, say Alex, and the email, alex@email.com, and the password, well, if your password for your email and the password for your accounts are the same, that person can see your password, see your email, and log into your email address potentially, or maybe Google your username and see what other accounts you have, maybe accounts of a similar variety, maybe social media, for which you might have used the same password. That's really dangerous. You can't trust server administrators to maintain this information securely because they could be incompetent, they could have a disgruntled employee, or they could just be plain out malicious. So use a different password for every service and make it random and make it cryptographically secure. Remembering long gibberish strings is hard, so we use a password vault to protect all of those randomly generated passwords behind one master password. You log in once and then LastPass takes care of the rest. LastPass have a promotional video on YouTube, probably you can search if you want to see it in action. Next, I'm going to install a staple that everyone probably uses, some kind of ad blocker. I'm going to use uBlock because it's a little bit faster than AdBlock Plus. uBlock obviously blocks adverts, which is great, makes you a little bit more secure as well. Next, I'm going to install an extension called HTTPS Everywhere. HTTPS Everywhere is great. So if you go, let me show you an example. It's not installed. If you go to http://twitter.com, watch this. As I press enter, I get automatically redirected to https://twitter.com. The Twitter server is configured in such a way that if somebody tries to access their login page without HTTPS, they automatically redirect them to use HTTPS. Other websites don't do this, and what HTTPS Everywhere does is it will automatically take you to the HTTPS website irrespective of whether the server is configured to do it or not. So it means you're going to be using HTTPS when possible. And obviously when you use HTTPS, your HTTP traffic is encrypted. Next, I'm going to install an extension that I'm kind of new to. It's called Disconnect. And it's supposed to increase your speed, the speed of your web pages, and your privacy by shutting down ad trackers and social widgets and other snooping elements before they load. It's maintained by some really smart guys. I don't remember what company they came from. It might have been Facebook or Google or something, but the guys behind it are really smart. And yeah, it's a pretty nice extension to have to stop trackers. Just as a little personal preference, I like to hide these buttons. And, you know, obviously I'm not going into too much detail because this video is getting pretty long as it is. And you can just Google the extension if you're interested, and you're going to see a really nice page that explains it in a much more succinct way than I could. But yeah, they're the extensions that I use for security. Just as an aside, I also use a couple more: Postman for sending post and get requests and stuff for web development, and JSON formatter to format JSON. It's all web development stuff. But yeah, they're the security extensions I use. Okay, this has been a long video, I'm pretty sure, and I really appreciate you guys sticking to the end if you did. Thank you so much for watching. This is the final video in my series on switching to GNOME. If you did enjoy it, please subscribe, and feel free to interact with any of the videos by leaving a like or a comment. If you have questions especially, please leave a comment and I'll be happy to get back to you. If there are any inaccuracies in what I've said, then I also apologize. Like I said, I'm not claiming to be an expert, but this is what I do to secure my system, and hopefully you enjoyed. Again, thank you for watching.